So that's it for the announcements. And now it's my huge pleasure to introduce Eugenia Cheng, who is our keynote speaker. She's a mathematician and a pianist. She's the scientist in residence at the School of the Art Institute of Chicago, and she's come down here to speak to us. She's also an honorary fellow in mathematics at the University of Sheffield in the UK. And she's a well-known category theorist. She's done work in higher dimensional category theory, did a PhD at Cambridge with Martin Hyland, who many of you know, and is one of the two instigators of the hugely popular Catsters YouTube video channel, providing good introductions and tutorials on interesting bits of category theory. So I highly recommend that. I learned a lot from those videos. Her main aim now is to rid the world of math phobia, and she's authored a series of popular, very successful books. You may know How to Bake Pi, Beyond Infinity, and the latest one that's just come out, The Art of Logic: How to Make Sense in a World That Doesn't. And I've read a review of this in the literature section of the national paper, the Guardian in England, the Saturday paper. So she has reach that we mostly don't. My papers never get reviewed in the Guardian. I think it's highly appropriate that on the outside of this building, there's an inscription from Woodrow Wilson, which I will read to you. I have to take my glasses off. So the inscription says, "Simple means should be found by which, by an interchange of points of view, we may get together. For the whole process of modern life is a process by which we must exclude misunderstandings, bring all people, we would say today, into common counsel, and so discover what is the common interest." And I think that's highly appropriate for what Eugenia's been working on and hopefully going to talk to us about. She's going to talk about conveying the power of abstraction. So, Eugenia.
Hello, everyone, and thank you for coming to hear me speak this morning. And first of all, I'd like to thank the organizers for inviting me to share some of the things I've learned about how to convey the power of abstraction to people who might be skeptical about it. And this is what I spend a lot of my time doing now. Because as scientist in residence at the School of the Art Institute of Chicago, what I do is I teach abstract mathematics to art students. They're all doing an art degree. It's a fine art school. It's a very serious school, but for art. So they're very serious students, but about art. And the really fun thing for me is it means that math is fun on the side. So at normal universities, math is part of your core central curriculum that everybody's forced to do, and they might get some art on the side if they're lucky. But here it's all the other way around, which is great because it means I can do anything I like. Nobody minds what I do. There's no curriculum restraints. I don't have to aim to get them into the next class. There's no post-requisite. There's no prerequisite. It's not the prerequisite for anything. Nobody is looking at what I do. As long as I and the students think that I'm teaching them something interesting, then everybody's happy. And the students do seem to think that I'm teaching something interesting. And when I say I teach math to art students, people often say, oh, does that mean remedial math, like catching up on times tables? And it absolutely does not mean that. If you follow me on Twitter, you'll see that I often get into vehement arguments online. Who gets in vehement arguments online? Imagine that. About the importance of timetables, or rather the lack of importance of timetables, in my view. Because math is about so much more than that. It's not just about numbers and equations. And it's not just about solving problems. It's really about thinking more clearly in a very specific way, involving logic and abstraction. And when I show it to my art students as a way of thinking better and a different point of view, they get really interested in it because they're really interested in thinking more clearly. There are loads of people who go, oh, I'm terrible at math, or I don't need math in my daily life. I've never used any of the stuff I learned in my math classes. And that might well be true because the stuff that you learn in math classes is incredibly specific and not terribly relevant. I think the curriculum is failing because it's just not very relevant to most people's daily lives. But that doesn't mean the whole of math is not relevant to people's daily lives. So I believe in finding the parts that I really do think are relevant. And I do think there are parts. And it's really the abstract parts. It's not solving a differential equation. I've never solved a differential equation in my actual life. I've never solved a differential equation anywhere outside of a math class and when I was teaching a math class. And so what is it that I use in my daily life? It's really abstract thinking. And as that wonderful Woodrow Wilson quotation said, it's about finding some simple means to connect different things in different areas of life. And when you can simplify things in that way, rather than simply ignoring important details, you can make tons of connections between things and gain a huge quantity of new insight or better insight into complicated situations. And this, I find, really motivates my art students and other people outside the school, because I give a lot of public talks to people of all ages, and everyone from small children up to retired people who have decided to regret not knowing more math. Everyone has found it to be illuminating. I shouldn't say everyone, because I don't know. Some people get really mad at me for stuff, obviously. There's always those people. But many people have found it illuminating. And one of the things I love about my job now, teaching art students, is I learn a lot from them about what put them off math before and what can put them back on it. And then I spend the rest of my time sharing what I've learned with as many people as possible, including you. So that's what I plan to do today. And I'm basically going to show ways that I convey the power of abstraction in various aspects of general life. So I like to think there's a kind of Newton's law of motivation that says the acceleration of your mind is proportional to the net forces acting on it. So there's a force in one direction and there's a force opposing you all the time. And so to be motivated to do something, you don't just need a reason to do it. You also need an absence of reasons not to do it. And it just means that the reasons to do it have to outweigh the reasons not to do it. So the aim is to achieve motivation that's greater than anti-motivation. And you can do that in two ways. You can get people more motivated, and you can also decrease their anti-motivation. And it's important to do both of those things and to understand what motivates people and what anti-motivates people. And my first book, How to Bake Pie, was all stories of food to explain abstract mathematics. And that's because when I was teaching at the University of Sheffield, I discovered that the thing that seemed to most motivate those students and wake them up was when I talked about food. And so I used that. With art students, I have found that the thing that most motivates them is questions of social justice. And so I use that now. And there are various things that have put them off math in the past, which accounts as anti-motivation. And so that includes that they found it painful for various reasons. So I try to show that it is fun, so that the fun outweighs the pain. And we all deal with some amounts of pain in order to achieve something in our lives. I mean, I used to be extremely unfit and quite fat, and then I got fitter by going to the gym. And it's a little bit painful, but it's also fun enough that that outweighs the pain. And the same is true of doing math research. It's pretty painful. You spend weeks, years, possibly bashing your head against brick walls, but it's kind of fun at the same time. And so if you can find the fun to outweigh the pain, then you don't have to make it completely painless. So the next thing is that it is difficult. It can be difficult, but it can also be rewarding. And so if you can make it more rewarding than it is difficult, then the difficulty becomes worthwhile. You can also make it less difficult. And this is an important thing because many people find math difficult because it was never really properly explained to them. And often it's taught very algorithmically because it takes too long to explain it to people, and because if you have a whole class of people with different range of abilities, then they all need different explanations, and that's very time-consuming. And so the fault is in the education system that we have and the lack of resources that we have for really being able to respond to people as individuals. So another thing is this question of usefulness and irrelevance. And math has an odd problem that it often pushed too hard for being really useful. And if you say that something is useful, then that doesn't make it sound interesting. It's like saying, hello, I'd like you to meet my friend. They're really useful. But I've gradually come around to the idea of usefulness because I don't want to say that math is not useful, because I really think it is. So instead, I try to portray the fact that math is useful because thinking more clearly is useful. And because math enables you, or is a way of thinking more clearly, that is useful. It's not about solving specific problems. It's not about splitting a restaurant bill or calculating a tip or figuring out how much reduction you'll get in the sales. It's about thinking your way through complex situations. And that really is useful. Whereas the old-style ways of showing that math are useful typically involve highly irrelevant questions that are very contrived and nothing to do with your actual real life. The kind of thing that says, you buy 87 watermelons and you drop 23 of them. That's not realistic. It's very contrived. So my favorite one of those was a homework question that a friend of mine sent me that her children got that said, you have 1 meter of string. You use 30% of it to tie up Eddie. You use 0.35 of it to tie up Joe. How much string do you have left to tie up Sally? And apart from the question of why we're tying people up in the first place, a meter of string is not very long to tie up 3 people. And everybody sees through those problems. And I love it, especially when small children see through those problems and write hilarious things. There was another one that the same person sent me where it was someone comparing different walkie-talkies at shops that had various reductions. And then at the end it said, which one do you think that he buys? And they said, none, because he's so fed up with going around all these shops. So the last thing is that math can seem very confusing to people, especially if it's not explained well. And people often say to me that they're terrible at math. And I want to say, I don't think it's you that's terrible at math. Maybe it was just your high school that was terrible at math. Or you didn't fail high school math failed you. So if math is confusing, we need to explain it better to show that the whole point of it is to illuminate things. It can seem like just a series of rules to cause pain, to stop people getting into things that they would like to do, and to confuse everybody. And unfortunately, some mathematicians present it like that, because some people derive all their self-esteem from being able to do something that other people can't do. And thus, they have to make it confusing to make sure that other people can't do it so that they can carry on feeling clever. And I don't believe in that. I get my self-esteem from helping other people to understand things that they previously didn't understand. And I hope that those of us who get our self-esteem in that way can gradually take over the world so that we can have a better world. So, thank you. So I say that pure mathematics is a framework for agreeing on things. And it's important for us to have frameworks for agreeing on things in life so that we can agree on things. Unfortunately, there are a lot of people who don't want to agree on things at the moment, and life has become more about shouting people down and proving that other people are wrong, rather than finding any points of agreement. And that's why I really liked the end of the Woodrow Wilson quotation, which I've now completely forgotten, but I think it was something to do with that. I logged it in my brain as something to do with finding things in common, or rather than always finding differences. And mathematics, pure mathematics, has traditionally had this image that it's really far away from real life, and that pure mathematics is only related to real life via some other things. And I used to think this as well. I thought my work is relevant because, well, it's useful to applied mathematics, and applied mathematics is then useful to science, and science is useful to engineering and medicine, and that's useful to the numerical part of the human world. And that is a very restricted view of what pure math is. And it enables people to say that they don't need it, because you can say, I'm really happy that somebody else is sorting out all the computers and the planes and all those things, and I don't need to do it myself. And I think that's too narrow, because actually, pure mathematics is more than that. And I had a very gratifying experience at an event about math in the real world in London. I think it was the New Scientist. And everyone else was an applied mathematician. And they all talked about terribly amazing things like the flow of chocolate in a chocolate fountain, and cryptography and error-correcting codes on digital things and stuff like that. And I talked about abstract mathematics. And at the end, there was a panel discussion, and the audience asked questions. And one of the questions to the whole panel was, which parts of your research do you use in your daily life? And all the applied mathematicians said, I don't really use exactly my research, it's just the principles of abstract mathematics thinking that I use. And so I went, see, it's abstract math that we use in our daily lives, and that's my research. It's not a competition, but it was very gratifying. So I say that pure mathematics is about how to think, and that is thus relevant to the entire human world, or at least it should be. There are parts of the human world that maybe don't think as much as we would like them to at the moment. But anybody who likes to believe that they think, thus can't, well, they still can, but they shouldn't then ignore mathematics and say it's not for them, because it is about thinking. So here's what I'm going to talk about. I'm going to talk about analogies and how they come up in mathematics. I'm going to talk about how abstraction helps us see the interconnectedness of things. I'm going to talk about how abstraction helps us to see relationships between things, and that if we focus on those relationships, we can get new insight. I'll talk about how it helps us to pivot between different situations to see things from different points of view. And then I'll talk about higher dimensions, because I am a higher dimensional category theorist, so I love seeing that things can be clearer if you actually add some dimensions into a situation. So mathematics is fundamentally, well, it can be thought of as a theory of analogies. Because, for example, you say to yourself, if I have 2 apples and 2 bananas, there's something that those 2 sets of things have in common, which is that they're both 2 things. And so you say, well, that's not something that they can have in common. And then when you do mathematics, you take that analogy really seriously and call it an object in its own right. And that is what abstraction is. It's where you make an analogy between 2 things, but you don't just say these things are analogous. You say what it is that is causing the analogy, and you treat that as a new object. And that's a level of abstraction, because you've forgotten some details about the things at the bottom level. Now, the thing is that there are many different ways you can do this. It's not a unique construction, and that's why making analogies in normal life is a problem, because if you just say something is analogous to something else, then everyone can disagree about exactly what analogy you're making. So, for example, if I said that 2 apples and 2 bananas were analogous because they're both 2 fruits, that's still valid, but it's more restrictive. And so that means that we would have excluded examples such as 2 chairs, which are now not analogous. So if we go up one level further to the level of 2 things, we do get to include 2 chairs. And I have abstracted away from analogies in the real world, well, the actual human world, to find that when people get into arguments about analogies, it's usually because one person is using the lower level of analogy and one person is using the higher level of analogy. And so we get into arguments about whether the 2 chairs thing should be included or not. But because in real life we don't make the thing that's causing the analogy actually explicit, then we can have arguments. So this is a way in which abstraction helps us to be clearer about the argument that we're even trying to have. It doesn't mean we're going to agree, but it means that we have a better chance of at least understanding what the argument is. So here's a more mathematical example where you start with 1 plus 2 and 2 plus 3, and you get to, well, these are both examples of A plus B. And people often say to me, I was fine with math until the numbers turned into letters. And the thing about that is that if you don't know why they're turning into letters, it seems very mysterious. But the whole point of it is so that you can study a lot of things at the same time, which enables you to be very lazy, which is great if you're lazy like me, because you don't want to do the same thing over and over again. You want to save your precious brain power for the stuff where it's really needed, which is not this. So you could also say 1 times 2 and 2 times 3 are both examples of A times B. And then you can go one level further and say, oh, actually, A plus B and A times B are both examples of A blah B, where blah is some kind of binary operation. And that's the level that you usually get to. Maybe if you're doing a math degree, if you're a math major, you get to this in abstract algebra where you start thinking about groups with general binary operations. So the bottom level is kind of elementary school arithmetic, and then the middle level is kind of middle school algebra, and then it gradually goes up. And this is what happens. You abstract further and further, and you get to include more and more examples. It doesn't mean that the top level is the best. One of the important lessons that Martin Hyland taught me, my PhD supervisor, was that the important thing is to find the right level of abstraction for the thing that you're currently looking at. Some people just try and make the most abstract possible thing just for the sake of it, and that's not necessarily illuminating. The question is, what level is illuminating for the current situation? And here's an example that I think is very important about same-sex marriage. Because some people say that same-sex marriage is not the same as marriage, but their argument is it's not exactly illogical, but it's not at all fruitful, because they say, I think marriage should be between a man and a woman. Well, all they've said is that I don't like same-sex marriage because I don't like same-sex marriage. They've just said the same thing twice, which is not illogical, but doesn't get you anywhere. And so I think the issue is the level of analogy that we're going to here. So some people think that marriage should just be between an unrelated man and woman, and therefore gay marriage does not count. But other people say that it should be between any two unrelated adults, in which case it does count. Now, it's important to remember that there was a lower level, even lower than an unrelated man and woman, in egregious parts of our history, where people of different races were not allowed to marry. And so it was actually, marriage was between an unrelated man and woman of different races. And we've moved on from that. But some people say, but if we allow gay marriage, then that will lead to some other terrible things, because they think that we're actually making analogy at a higher level. Maybe they think that we're going as far as just two adults and that we therefore are allowing incest. I know there are no children in the room. I hope they're not watching on the live stream either. When I think there are going to be children, I redact this slide. So we could go up to the level of two humans, not just two adults, and then we would get pedophilia. And we could go further. We could go to the level of two living creatures. And we could go up further to the level of two creatures. Now, the point is that just because some of us believe in this level does not mean that we have spontaneously slid all the way up to the top level. But some people hallucinate and think that we have. And that is not a logical conclusion. It's a conclusion based on fear, prejudice, or assumptions, or something else. But what the important thing is for us to be able to be specific about what level we're going to, so that we can have a more sensible conversation about what level of analogy we're making, and saying just because we've gone up to that level, we're not saying that we're going up any further. And then I think we can have a clearer argument about the situation rather than just continued yelling matches. So my conclusion to this section is that abstraction has a point, and the point is maybe a bit surprising, but here are some things that we gain. We gain broader perspective because we get to include more examples. We get a deeper understanding because we get further into the heart of why things are really happening the way they are. We have wider applicability because if we go more abstract, we include more things. And we get more connections between different situations that previously appeared unconnected. And that can help to convince people that abstraction is worthwhile because they thought it was just something very arcane and floating around. And if they can find that it actually relates to things that they care about, then they will care about it more. So next, I would like to talk about interconnectedness and how abstraction allows us to see interconnectedness more clearly. So here's my favorite diagram of interconnectedness. It is the map of the London Underground. And one of the reasons I like it so much is because it is not geographically accurate. So I think it's really a categorical diagram because all it shows is the connections between things. And that's all you need to know when you're traveling on the Underground. You don't actually need to know where your tunnel is going when you're in the train. You just need to know where you can connect to different lines. Of course, because it's not geographically accurate, it also leads to situations with unsuspecting tourists taking a train from somewhere to somewhere else when it's actually really close, like Covent Garden to Leicester Square, which it only takes about 4 minutes to walk, but you can't tell that from the map. So here is a geographically accurate tube map. It's much more confusing. It would be very difficult to use this to get around London. That doesn't mean it's useless. It's useful for something different, which is it's interesting to see where geographically all the tube lines and the tube stations are. So there are different possible abstractions of the same situation. And so if one of them isn't illuminating for the situation that you're in, you can look for another one that's illuminating. And that is a very interesting flexibility. And one of the important things about abstract math is to be able to switch points of view a lot. And I really think that it's like the fact that being strong isn't about being strong and rigid, it's really about flexibility. And that I think the more points of view we can have on the same thing, then the better we will be able to grasp it. So here is a way that I think of interconnectedness in relationship breakdown situations. So those things often get into a terrible cycle where maybe there's one person in the relationship, Alex, who feels disrespected. And when Alex feels disrespected, Alex is unable to show love, which means that Alex's partner, Sam, feels unloved. And if Sam feels unloved, maybe Sam is unable to show respect, which means that Alex feels disrespected. And this is quite a typical cycle, I think, in relationships where two people have slightly different needs. So we could label these arrows as action because they're action responses, and these ones are feelings because they're feeling responses. And then once we've realized that it's an interconnected vicious cycle, then we can think about which would be the best arrow to try and break. And you might say, well, it's hard to control your feelings. You just feel the things you feel, so maybe what we should try and do is control our actions. So maybe even when Alex feels disrespected, Alex could still try to show love, and then we won't get into this cycle. Or maybe Sam, when Sam is feeling unloved, should still try to show respect. And then you can ask the question, well, whose responsibility is it to break the arrow? And I think one answer is that whoever is more mature should take the responsibility. Another answer that is maybe related is whoever has more power should take responsibility to break that. Because I think that people who have power should take responsibility for things more. So this is a vicious circle, and vicious circles crop up all over the place. For example, in the issue of police violence, especially in this country, against black people. So what you could say is that police feel threatened by black people, and so they aggressively defend themselves against black people, which means that black people feel threatened by the police, which means that black people aggressively defend themselves against the police, which means that police feel threatened by black people. And this is a very tragic, vicious circle that it seems extremely divisive because people yell about whose responsibility it is. They say, well, you should just obey the police. And then some people say, well, the police shouldn't use violence. So again, I think that we can think about which are the best arrows to break in this situation. And again, maybe it's both, because while it's difficult to control our feelings, why are the police feeling so threatened in the first place, despite the fact that they're the police and that they're in a position of power? So maybe they can be trained to feel less threatened, but importantly, to change their actions so that they don't respond by aggressively defending themselves, but do what maybe like what people in other police forces do, which is try to de-escalate situations rather than escalate them. And then you can get into an argument saying, well, whose responsibility should it be to change this? And some people think that it's black people's fault and it's their responsibility, they should behave better. But another point of view, and this is what I believe, which is that the people who have the power should take the responsibility. And in this situation, it's clearly the police. And so I think it's the police who should take the responsibility to break that cycle. However, if people disagree, at least if we're thinking about it like this, we can have a clearer discussion about the disagreement. So this section shows that abstraction can help us to see relationships between different interconnected systems. And that's what category theory does. It says, I'm just going to look at some interconnectedness in this system, and then if I look at some interconnectedness in this system, I can make a new analogy, an abstract point of view between the structures on both sides, and then I can study both at the same time. And once you think about vicious circles, then you can see vicious circles all over the place, and you can discover that when it's with people, they are often two feelings arrows and two actions arrows. So next I would like to talk about relationships, and this is something that I care about a lot because category theory is all about finding the relationships between things, and it's about the fact that you can understand an awful lot about something by looking at its relationships with the things around it rather than just looking at its intrinsic characteristics. Just like if you are writing a biography of a person, then you can understand a lot about that person by looking at their relationships with other people, their family, the partners they've had, the people they work with, and so on. And you can understand a lot about a person by looking at how they interact with different types of people, their friends, people they consider superior, people they consider inferior, servers in restaurants, things like that. And so I'm going to start with something apparently arcane that people may remember from school days and shudder, factors of 30. So you may have seen me talk about this before. I can see a few familiar faces in the audience, but I think it's very important. So not this exactly, but the insight we get from it. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. It's not very interesting. It's a bunch of numbers in a straight line. And I like to say that we live in a three-dimensional world, so we write on two-dimensional pieces of paper in one-dimensional straight lines. So we stuff our thoughts into one dimension. And maybe they don't want to be in one dimension. Maybe they have natural geometry in higher dimensions. And I like to say this is why I do not tidy the papers on my desk, because they have natural geometry in higher dimensions. So here is the natural higher dimensional geometry of this situation. We can look at relationships between the factors and look at which ones are also factors of each other. And we can draw a kind of family tree showing which ones are factors of each other, and it's in fact a category where the arrows are showing factors of things. So 30 is at the top, like the kind of great-grandparent, and then 5, 10, and 15 are factors of 30 directly. And just like in a family tree, we don't need to draw arrows across 2 generations. So here we have that 5 is a factor of 10 and 15, but we don't need an arrow from 30 to 15 because we can deduce it. So in the language of category theory, it's because it's a composite of the arrows via 10 and 15, and that square commutes. So there's just one arrow from 30 to 5. We have 2 that's a factor of 6 and 10. 3 is a factor of 6 and 15. And 1 is a factor of 2, 3, and 5. So now we see it's the corners of a cube, which I think is a bit more interesting than a bunch of numbers floating around in a straight line. And if we go a little bit more abstract, well, we can start asking why things happen. And that's often a good way to become more abstract. So anyone who is curious and wants to know why things happen, maybe that is a drive to abstraction, because that can help us understand why. And that's certainly how I got drawn into abstract mathematics, by wanting to ask deeper and deeper why questions and not being satisfied until I got to a truly rigorous level of abstract mathematics. So why does this happen? Well, you might notice that at the bottom level above the 1, 2, 3, and 5 are all prime numbers. And that makes sense, because they're the things where nothing goes into them apart from 1 and themselves. So they should go at the bottom. And then at the next level, we have things that are a product of 2 prime numbers. And then at the top level, we have something that's a product of 3 prime numbers. And that's how this diagram comes about. So if we write it out in terms of sets of prime numbers instead, you can see what's happening at each level, that we're gradually getting more and more numbers. And now we can see that maybe it doesn't matter that it was the numbers 2, 3, and 5. It doesn't even matter that it was numbers at all. It could have been anything. And so we can turn the numbers into letters and make it A, B, and C. And now we have a diagram that is the same diagram, and it's the same category, but it's with different things at the corners. And we can think of it as subsets rather than factors. And so it's a category showing subsets of a set. And now we can apply it to other situations. So now we've understood that it was because we had 3 different prime numbers. We could try 3 other different prime numbers, like 2, 3, and 7, which makes 42. Here are the factors of 42. And then we can draw the analogous diagram, maybe starting at the bottom this time. So we know that the 3 prime factors should go at the bottom, then the products of 2 prime factors, and then the product of 3 prime factors. And if we write it out again in terms of its prime factors, we can see that in the middle diagram, if we replace every 7 by a 5, it goes back to being the other diagram. And that means that at the furthest level of abstraction, it really is the same. So we have gone abstract enough that more things have become the same. Now there's something in this left-hand diagram I want to emphasize, which is that 6 is less than 7. This might not sound very profound, but the point is that 6 is higher than 7 in the hierarchy of this diagram, even though it's smaller than 7 as a number. And when I do this exercise with my students, they often immediately start by putting 2, 3, and 6 on the bottom level, because they think the bottom level should be the smallest numbers. And that's not how it works. because this hierarchy, this partially ordered set, is not ordering by size, it's ordering by number of prime factors. And this is important because in life, if we have two different hierarchies on the same set and they don't agree with each other, that can cause antagonism. For example, if somebody is younger than another person but more senior than them at work, then that can cause antagonism. So anytime there are two hierarchies that disagree, we get into fights. And this is very relevant to my next example, because of course the whole point of turning things into letters is to include more examples. And so, for example, A, B, and C could be three types of privilege: rich, white, and male. At that point, the next level down is people with two types of privilege: rich and white, rich and male, and white male. And then the next level down is people with one type of privilege: rich, white, and male. And at the bottom, it's people with no types of privilege. Now, I can make this more emphatic by putting in the missing terms. So here we have rich, white, non-men. Here we have rich, non-white men. And here we have non-rich, white men. And I want to specify that it's non-rich, because sometimes when I talk about rich people and poor people, everyone in the room puts themselves in the poor people group and envies the rich people. But I'd like to stress that everyone in this room is rich compared with a lot of people. And so I'd rather that we all thought of ourselves in the rich category. So there's also rich, non-white, non-men, non-rich, white, non-men, non-rich, non-white men, and finally at the bottom, non-rich, non-white, non-men. Well, this is now a diagram where each arrow shows loss of one type of privilege. And this gives us some important things to understand about the theory of privilege. So one is that privilege doesn't mean that all white people are better off than all black people. Some people think that, or they willfully think that, and they point at some super rich black sports star and they say, look, there's a rich black person, that means white privilege doesn't exist. And that is not what white privilege means. White privilege means that if you lose that privilege along directly one arrow and everything else about you stays the same, if it did, then we would expect you to be worse off in society. Now, there are some groups of people in this diagram who are not comparable to each other in the language of partially ordered sets. So along each horizontal level, there isn't an arrow telling us about the loss of privilege because they're not compatible losses of privilege. But we can think about it in absolute terms, and then we can think that maybe we can all agree that rich, white, non-men, for example, rich white women, are probably better off than rich black men, who are in turn probably better off than poor white men. And we can do the same at the next level down. And actually then we can compare between the two levels. Because if we think about rich black women, maybe we can agree that they could be better off than poor white men. Because it turns out money makes up for an awful lot of ills in your life. So actually maybe it's like this. So it's not a cube anymore, it's a cuboid of privilege. And this has helped me to understand why some poor white men are so angry at the moment. Because they are considered in the theory of privilege to be very privileged, but they don't actually feel any of the manifestations of that privilege if maybe they're unemployed or homeless and in the middle of America with no chance of getting a job. And so they get angry about it. And I think it's much more important to think abstractly and understand the root of that anger rather than simply getting angry at them in return. So, thank you. So I say that abstraction helps us to understand complex relationships between different groups of people. And the difficulty with complex relationships is that they're complex. And one way to simplify them is to oversimplify them. But a better way to simplify them is to become more intelligent, because then they become simpler relative to your brain. I think abstract math helps us do that. So now I'd like to talk about how abstraction can help us to pivot between different situations. In these three cubes, we saw that 30, 42, and rich white men were analogous in those situations. And so we can compare their roles within those situations. And this is something that category theory does a lot. It's where universal properties come in. And so we could do this with individual situations of power relationships. So we can say, well, the power that male people have over female people is in some sense analogous to the power that white people have over black people, which is also in some sense analogous to the power that rich people have over poor people. And then we can use those analogies to help us understand what it's like to be in a different part of the diagram, because we're all in different parts of different diagrams, so we should all be able to understand it from those different points of view. It also helps us see that if we look at the relationship between male people and female people and compare it with the relationship between female people and male people, that is not analogous because the arrow is pointing in the opposite direction. And this gives us a sense in which sexism of male people towards female people is different from sexism of female people towards male people. There is also a sense in which they're the same if we go up to a higher level of analogy, because it's both people being terrible to people. But maybe that's not the most illuminating thing to think about, and then we can discuss which level is more illuminating. So something might not be at the top in one context, but be at the top in another context. For example, in this diagram of rich white male privilege, the rich white men were at the top. However, if we restrict to this part of the diagram, we see that the rich white non-men were at the top. And we could try restricting our attention entirely to women and using rich, white, and cisgendered as our three types of privilege. And now we see that rich, white, cis women in this diagram occupy the analogous role that rich white men did in general society. And this has helped me to understand why there's so much anger towards white women at the moment, especially in some parts of the feminist movement, because they might tend to see themselves as underprivileged relative to the white men they typically mix with. And then they don't see that they're much more privileged than all other women. And that causes antagonism. So all of us are more privileged than somebody and less privileged than somebody else. So we can all perform pivots to understand what it's like to be on both sides of that power difference. And here is a pivot that I find interesting in my life, which is that as an Asian person, I am not white, and so I am less privileged than white people in that sense. But I do think that Asian people are among the most privileged of non-white people. And so I can pivot between the feeling of underprivilege and understanding that I am in a position of privilege over other people, and thus I can try and understand what it's like to be in those different positions. And I can think about how I should treat those who are less privileged than me by thinking about how I would like those more privileged than me to treat me. Another situation is about wealth. So there are people who are richer than me, and there are people who are poorer than me. So there are people who are so rich that they don't need to work ever again. I'm not that. But I'm also doing fine, and that's better than people who are really struggling. And so if we tend to think of ourselves as being poor and those rich people need to do more things, don't forget that we're also richer than other people, and they're looking at us saying, well, we're doing fine, we should do more for those people. So another important one is the one I just mentioned about white women. If white women only ever see themselves in the underprivileged position relative to white men, maybe because they mix in mostly white society, then they are being short-sighted, and they should remember that they are more privileged than non-white women. And this an analogous situation can arise whenever there are two types of privilege, and you have one of them, because then you might only look at the people who have the other one, and you might forget to look at the people who don't have either of them. So in this sense, abstraction can actually help us empathize with other people, which I think is a possibly surprising conclusion, because abstract mathematics is not thought of in the same breath as empathy a whole lot. But I really think that abstraction can help us with empathy by taking the emotions out of the situation. So if we disagree with someone vehemently and emotionally, we can get very upset about it. But if we unpack their logic and the logic of the situation, then it can help us see their point of view instead of trying to connect with them at an emotional level. So finally, I'd like to talk about higher dimensions, because if we get good at abstraction, then we can think in higher dimensions, and often things like we just saw have a natural geometry in higher dimensions where they're oversimplistic in one dimension. And one of the examples that I see coming up all the time is the kind of questionnaire you get that says, I prefer cake to ice cream. How much do you agree with this statement or disagree with it? And they typically give you something like this, where you can check strongly disagree, disagree, neither agree, or strongly agree. And in almost all of these questionnaires, I find myself wanting to say that I strongly disagree and I strongly agree. Because sometimes I really like one and sometimes I really like the other. And this is the thing is that if I say neither, then it sounds like I don't like either of them, or I can't be distinguished from someone who doesn't really like cake, doesn't really like ice cream, and that's really not me. And so really this should be a two-dimensional diagram. How much you like ice cream being on one axis, how much you like cake being on the other, and you can be anywhere on this diagram. I'm here. And then we can see that actually the entire line of liking cake and ice cream equally is this line. It's the x equals y line. And so there are a whole load of different ways to be on that line. You could hate them both equally. So what's actually happened is that we have pretended that this is a zero-sum game, or rather a four-sum game, where however much you like one of them, you like the other one 4 minus that. And that means that the dots that we've put are on here, which is the x plus y equals 4 line, I think. And we have accidentally squashed the entire x equals y line into one point. And so we've lost all of that extra dimensionality. And there are so many situations where this happens because we accidentally turn something into a zero-sum game that doesn't need to be. And that's also a way that people can control other people, by making a zero-sum game that says if you do anything to help yourself, then you're hurting me and that makes you a horrible person. But then I think the problem with that is whoever made it into a zero-sum game, and that we should try to work hard to make things into not zero-sum games, to get out of those power situations. So here is another example I come across a lot at art school, where there's a question of do you prefer science or art? And some of my art students tell me they previously got turned off science and mathematics because they thought that you couldn't like both at the same time, and they knew they wanted to be an artist, and so they concluded that they had to hate science. Now that's not true at all. That's a false dichotomy. You can like both or neither, and it's a two-dimensional graph, and again, as usual, I'm here. So again, here's another one. I prefer beauty rather than usefulness. Well, yes, I think it's a two-dimensional graph, and I'm here. And then there's also, most relevant to this talk, I prefer real problems rather than abstract ones, which is sometimes something that people, an accusation that they level against abstractions. They say, well, that's all very well, but I prefer things in the real world. And I say, well, what is the real world anyway? What is real? Is anything real? Am I real? I don't know. But I think it's possible for something to be real and abstract at the same time. And that's where I am. I like the things that are real and abstract, so that the abstraction gives us more insight into the real things that we're dealing with every day. And so finally, my last two-dimensional picture is from Carlos Chipola's theory of stupidity, which I like a lot. It's sort of tongue-in-cheek, but I think it has a really important message. So his first starting point is to say that he thinks that in every group of people there is the same proportion of stupid people. Whether you're talking about academics, students, children, prisoners, street cleaners, toilet cleaners, politicians, maybe there's more stupid people in politicians. And so he says that not only is there the same proportion of stupid people in every group, but it's always more than you think it's going to be, even when you've taken that into account. So then he has to make a definition of stupidity. Well, he should, and he does make a definition of stupidity, and it goes like this. There are two axes. One of them is how much you benefit yourself, and the other one is how much you benefit others. So if you are in the bottom right-hand quadrant, then you benefit yourself while hurting other people. And that, he says, makes you a bandit. If you're in the top left-hand quadrant, then you benefit others while hurting yourself. And he says that makes you unfortunate. And this is an important lesson that I wish I had learned earlier in my life, because I thought it was noble to sacrifice oneself in order to help other people. And it's possible that this is particularly something that women get taught in their whole lives, that self-sacrifice is what women do for the benefit of everyone else. But what I realized was that in my job, I was trying to help people in education, and I was more and more miserable, and all I was going to do was turn myself into a wreck and then limit my ability to help other people. So if you are in the bottom left quadrant, then you hurt other people and you hurt yourself at the same time, and that is stupid. Which leaves the top right-hand quadrant, where you benefit others and you benefit yourself at the same time. And that is what Chipola says is intelligent. And I agree with that. I don't think intelligence is about how many degrees you have, or what grades you got, or how much money you have, or what position you have in society, or your job title. I think it's about how much you can help other people and help yourself at the same time so that we can build a better world. And so I say that abstraction can help us create a virtuous cycle where logic helps us with empathy, and then empathy can also help us to take action with logic. And so, to conclude, I say that abstraction can help us create this virtuous circle, and I hope that we can all use abstraction to help us go out into the world and be intelligent. Thank you.
Thank you very much, Eugenia. That was fantastic. We have an assortment of questions here. So there's one from Joey Eramondi. He says, for the vicious circle examples, you say that those with the most power should initiate breaking the cycle, and I agree with that. But it seems somewhat subjective. Do you have any insight into how to apply mathematical thinking to arrive at that sort of judgment?
It's an interesting question, and the point I think that's important to remember is that logic has to start somewhere. We know that there are axioms, and that any logical system has to start with some axioms, and then we build up from those axioms. So some people think that the aim should be to be completely rational, and I don't think that's possible, because you can only deduce things from other things. So if you don't start with anything, then you can't deduce anything from it either. But the aim should be to figure out as far as possible back through our basic axioms to find really fundamental axioms that are really fundamental beliefs. And if we work our way back logically through people's beliefs, even if they can't do it themselves because they're not equipped with those abilities, we can do it for them, and we can try to understand what the really fundamental point of disagreement is between us. And I find in questions like that, it often comes down to whether people believe in an individual taking responsibility for themselves, or whether they believe in people being part of a community and acting in a community as a whole. And once you've made it back down to that particular fundamental belief, then you can try to have a conversation about the fact that it's not a black and white situation, that actually there are situations that we should take individual responsibility for, and there are situations that we should take group responsibility for. So I believe in that there should be group responsibility for things like healthcare and education. Unfortunately, not everyone agrees with me. But I don't believe that we should take group responsibility for paying for somebody's lavish wedding with a Kickstarter, for example. And so once we realize that there's a gray area in between, then we can try and build what I call a gray area bridge between the two positions, to say we don't actually completely disagree, we're just sort of positioned somewhere slightly different in the gray area. And then once you've found that you're in a gray area rather than on two completely different sides of the coin, you have more chance of having a fluid conversation and reaching an understanding, rather than the idea sometimes we have that we have to change somebody's mind, which I think is futile and also arrogant, and that what we should try and do is find points of contact in this gray area instead.
Great, thank you. A question about your teaching. What sort of assignments do you use for your students? Or put it another way, how do they learn abstract thinking?
Well, there are no grades at art school, which makes it an ideal place to teach. And so it's all pass-fail. And so I tell them, as long as they show up to every class and participate in the conversation, then they will learn abstract mathematics. They will not be able to stop themselves learning abstract mathematics because of how we interact. So in class, I always have some kind of hands-on project that is what they call low floor, high ceiling, so that everybody can get into it, but there's no real limit to the stuff that you can learn by doing it. And whatever you do, you will learn something about abstract mathematics. So there's no particular aim in mind, and you don't have to try and get the right answer. You just explore the situation, and you will find out something. So, for example, we cut out regular polygons and try and build the platonic solids just from principles of symmetry. And some people will build the platonic solids, and some people will build some things that are partially symmetrical but are not actually platonic solids, and they still discovered something. And some people will build a dinosaur. And even if they build a dinosaur, they've still discovered something, because they will find that pentagons are not a very useful shape for building a dinosaur. Whereas equilateral triangles, you can build practically anything. And that's actually a profound thing that gets used in topology a lot. And then someone went off and discovered this and then was a fashion student and started making clothes out of little equilateral triangles, which I thought was kind of cool. So those kinds of things are, as long as you don't have a fixed idea in mind of exactly what you want people to learn, as long as they're developing some notion of abstract thinking, then I feel that it's worthwhile. So I do give them also writing assignments where I get them to write the kind of, like the stories I write in my books, stories that encapsulate the principles of abstraction that I'm talking about, to have another way of seeing if they've developed that understanding.
Marvelous. You have a very sympathetic room here, perhaps, but in your experience, how well is this talk received by non-liberal audiences?
So there's a gray area, right? We shouldn't just call people liberal and non-liberal. There's a whole range of things that people can believe. And yes, there are some very extreme people who are very, very far away from what we believe, and we might not be able to reach them yet. But there are people in between who, so the nearest people, I would say, are liberal people who aren't very good at logic but want to be, and who still do things like post articles that they haven't fact-checked, and that in about 10 seconds you can fact-check them and realize that it's a load of rubbish. But they mean well, and so we can reach those people and get them to do better. Then there are people who are logical but just have some different fundamental axioms from us. And we can reach them as well, because we can talk about what our fundamental axioms are and encourage them to really pin down what the fundamental axiom is and then have a conversation about that. Now, it's true that the people who are absolutely obstinately at the far end, who refuse to believe anything they say, and I've had some people in the audience who I suspect were going to refuse to believe everything I say just because I'm a woman. And I've had 2 people like that in a very conservative book festival I spoke at in England. And it was clear to me that they'd set out to disbelieve everything I say. And of course, those people are very extreme, and maybe we can't reach them yet. But that doesn't mean that we should give up completely, because there's all these other people in between. And if we can shift the whole kind of center of gravity of logic of the world just a bit more this way, we only have to shift it a bit. It's not like we have to turn everybody into paragons of virtue immediately. And so if we decide that it's fruitless because we can never reach those people, then it will be fruitless. We will make a self-fulfilling prophecy if we decide in advance that we can't do it. And I think that no one will benefit from that, except possibly it releases us from having to take the responsibility of trying to do anything about it. And I think we should take responsibility for trying to do something about it. So here I
am. Here's one that is phrased in a negative way, but I suspect you're going to be able to put a positive spin on it. So, do you find that mathematical thinking teaches you to be more skeptical and pedantic, and that people perceive it then as negativity or pessimism in real life?
So, pedantry is something that I address very specifically in my latest book, The Art of Logic, because I was thinking about it, because yes, I do get accused of pedantry, because I am a mathematician, and we all do. But what I think is, what is the difference between precision and pedantry? I think that precision and pedantry are different because of whether they're illuminating or not. So I think that pedantry is just precision that is not illuminating anymore, such as when people insist that you should use an Oxford comma, even when it doesn't make any difference to the sense whatsoever. That's one of my pet hates. So the thing is that different people are seeking different levels of illumination. And so if you're happy wandering around in the dark, then you will find some extra precision, pedantry, because you don't even care about that kind of illumination. And so in order to persuade people that we are being precise and not just pedantic, we need to persuade people that there is something illuminating that we have to say, rather than just going on about it. And if we can't find anything illuminating about it, and sometimes people are just trying to assume a position of superiority by just arbitrarily being more precise, that is pedantic, because there's nothing illuminating about it at all. So I think if we can focus on the sense in which our precision is illuminating, then we can change people's minds about it.
Marvelous. A last question, I think. Do you find many real-world analogies to be leaky and not suitable for categorization? For example, dealing with spoken languages can have differing interpretations, so a classification might seem reasonable but does not transcend people's interpretation.
I think that all analogies are, in some sense, leaky because they're analogies, and so they're never going to be the exact same thing as each other. And in all cases, instead of saying whether this is an analogy, a good analogy or not, we should do one of those diagrams where we say, okay, in what sense is this an analogy? In what sense are these two things the same? And in what sense are these two things not the same? And then decide which of those positions is more relevant to the situation that we're thinking about. Because it can be really illuminating to temporarily think of two things being the same, even if they're not at all, just to see how far we can get. As long as we bear in mind that there is this other sense in which they are not the same, rather than staying fixed at any level of abstraction. So I think the key to all of this is not to be fixed in the point of view that you're taking, and not to think there is one point of view or one level of abstraction that is going to be correct, but rather there are a lot of different ways that we could think about things, and we should move between them and find the one that is most helpful to the world around us.
Great. Thank you very much. I think we should stop there, and we should thank Eugenia again for a fantastic talk.
Thank you very much.